every session, and then
Okay.
at the end of the session, we'll share these videos to you. Okay, so let me first introduce myself, Arun. Mm, my name is Vijay Vishkarma. It's there in the screen now. I'm a solution architect and as a consultant in both DevOps and Kubernetes, as well as in public cloud. So I have mainly experience in all the public clouds, all three public cloud, but mainly on Azure and AWS. I'm doing very good. I have run through almost more than 25 application and platform architecture and design I have completed, and lots of supports, lots of pre-sales job also I have done. If you see my certification so far, so I'm in Azure, AWS, DevOps engineer expert, DevOps engineer, and then Kubernetes. If you see all these three certifications I have covered, and DevOps, I'm working in all these much of technologies like Ansible, OpenShift, Red Hat, and Docker Associate and programming languages, Python.
Mhm.
Moreover, in Terraform also, I'm very much doing good. These are my contacts. Uh, so now, Arun, it's your time to introduce, let's say, yourself about what you're doing, how about your career so far, and let's say your background. As you said, very high level that you come from Windows background mainly, and that's why VMware is there.
Yeah, so okay, background wise, I've been working in VMware for last 5 years. So in terms of my expertise, it's more towards virtualization, virtual desktops, cloud management as well. I do have some decent, so in terms of certifications also, I have a few VMware and AWS certificates.
Mm-hmm.
Um, and yeah, so with regards to Kubernetes, I have done pretty extensive studies myself personally, so I know most of the basics.
Mm-hmm.
Um, yeah, as I mentioned earlier, the purpose of this class is really to go deep in the technology.
Okay, great. Okay, so Arun, so they, I mean, when we'll be starting, let's say on the CKA part, we'll be definitely covering all those agenda based on the CNCF website,
Hmm.
and I'll put all those backgrounds. I didn't get enough time to be very honest to get all those backgrounds drafted here in some slide and let's say incorporating those training agendas here, but I thought to spend at least 2 days time to introduce with ourselves, and then we can go ahead and talk a little bit about the CKA, CKAD, and CKA certification path. Hope you already aware about it, but then we'll discuss a little bit technically in what is Docker, what is container, basically what are the different components like CRI, CNI, etc., etc. So the
Hmm.
screen which you are seeing right now, the I'm talking about the training delivery model so far. So I have two screen. The screen right now you are looking is on my iPad, and the reason I'm using it because so that I can use this
Yep.
Apple Pencil, okay,
Okay.
to make you aware about our theory. And then second is I have a screen of my MacBook where I can open my terminal and I can run commands, and I'll give you the demonstration of let's say Kubernetes and how multiple objects are working there.
Yep.
And because I'm coming from a production background, I'm coming from an enterprise background, and it's working Kubernetes in my day in and day out activities. So feel free to discuss anything. We'll make this session interactive as much as possible, and my all the examples would be coming from let's say the real time scenarios, everything from enterprise environment which we are day in and day out let's say facing, and mainly the solutioning part, lot of components, lot of concepts, lot of options, and a content rich presentation and content rich training delivery will be making it. So the motive is not only to understand about CKA, but with CKA whatever things we are capturing, uh, we should have a let's say larger and deeper understanding on all this stuff.
Yep. Yep.
This is how we'll be moving. So I have a single slide, by the way, so far, just for your understanding and just for my introduction with you. Okay.
Okay. Okay.
Okay. So this is my training equipments I'm using. So I'll mainly use this Blackboard. to draw something, or let's say we'll
Okay.
interact with each other. Okay, so we'll discuss about, I thought to discuss first of all today about some of the components, like mainly the container, because it's a basic building blocks. We'll little bit high level discuss about why Kubernetes. Okay, and what are the different, when we talk about Kubernetes, we're talking that it's a orchestrator, right? So
Yes.
what is the function of orchestrator? Why is this orchestrator is there? And if Kubernetes is not, then what else? And if container is not, then what else? Okay, and you
Mhm.
said rightly that you are coming from VMware background. So I will try to, my all the examples would be coming from VMware. Okay,
Sure, sure.
so so that the correlation you can make, an understanding you can build up.
Yep.
So okay, so this is now. So let's first talk about, with we're starting now, and let's first talk about the container. Mhm.
Yep.
Container, what's the benefit? And by the way, it is good, right, Arun? If I can start everything from scratch.
Yes, yes, yes. It's
Okay.
fine. But I think this part we can probably go a little bit faster. But yeah, we should start from the
Yeah,
scratch.
definitely
Yep.
we'll go faster, definitely. But just some of the questions which is always coming in while in we are there in introduction also. I mean, taking, I'm not going into depth about what is container. Container is definitely very high level. It's a kind of directory. Containers are nothing but a directory where in this directory we have uh, application code, plus we have libraries supporting to run this application codes, and then we have binaries of services which requires to run. So minimum set of libraries, minimum set of binaries plus application code is something we called it as a container, right? It's
Yep.
a container. So that's a operating system. This part is my operating system container image, and this part is my application code. I'm getting it from Git, let's say, or any other SCM tool.
Yep.
So while creating Docker images, just like in VMware we have templates, similarly in Docker we have uh, images. There are templates. We have images. If we talk about, let's say, the orchestration over here, or differentiation, if I would say, what is the difference between, what is your understanding about difference between VM and container? Basic. So
So
what would be your answer?
yeah, my understanding is that container is like another layer of abstraction compared to so for a virtual machine, typically it's an abstraction of an OS from the underlying hardware, whereas for a container it's an abstraction of the application and the binaries from the underlying operating system. So you
Yeah,
can
you
break it
said is
down.
totally right. So
Yeah,
in, if I'm drawing a picture here, then there would be obviously the hardware, and then I would have operating system, let's say, not the operating system precisely. It would be my hypervisor,
correct.
and then there would be OS,
Yes.
and then obviously the app which I'm using. In container, scenario is same. Differences we'll talk about, but the scenario is same. That's why I said I will start talking about VMware also
Sure.
parallelly, because I want you to correlate things there. I
Sure.
understand you already have these understanding there, but definitely. So instead of hypervisor, what we are using here is container engine. Now we are not talking about container engine only, we are talking about CRI. What is it? It's a container runtime interface. Okay, CRI uh, is just like your hypervisor. We have a hypervisor as a terminology. We can have multiple types of hypervisor, right? We can
Yes.
have Citrix Zen, we have VMware, we have KVM, lot of hypervisor, but
Correct.
at the end the terminology we are using is hypervisor. Similarly, the terminology in Kubernetes or let's say in Docker we are using is a CRI. It's a container runtime interface. Container runtime interface, you can similarly there is hypervisor, there is CRI. Now just like hypervisor we have many vendors. Similarly for CRI we have many, you can say, because it's open source, so I would not say vendors, but I would say there are many uh, open source products
Yep.
just like CRI. So Docker is one of them.
Correct.
Okay, there is Docker, there is Containerd, there is Cryo, it's a CRIO, let's say, and Red Hat is right now talking about Podman. So these are four majorly use CRI. It means container runtime engines. These are the engines or interfaces which can run containers, which can enable operating system, let's say, to run the container on top of that, just like the
Mhm.
hypervisor. So what is there similarly? So we have multiple containers instead of VMs. This is my VMs,
Yep.
OS and application. Similarly, we have containers. What is there in containers? We have container means libraries plus binaries, and then we have app code. Similarly, okay, this is my container.
Okay.
So far so good.
Yes.
Okay, so just like the VMware, we can have lot of VMs running, but to make them highly available, we need orchestration layer, right? We need ESXi nodes, and to manage this ESXi node, what we have is vCenter.
Yep.
In ESXi node, we are running what? VMs.
Mhm.
Similarly, in Kubernetes, what we get is a VMs as host.
Yep.
These are workers. You can say worker, you can say data plane, you can say minions, anything. We got workers, and to manage workers, we got control plane or masters. Okay, and we are running what is? We are running here as containers. Similarly, now if you see the vCenter, vCenter we call it as an orchestrator, isn't it?
Yes.
So similarly, we are talking about that in Kubernetes, the master component or the entire component which is running there is we are talking that Kubernetes is an orchestrator. Now, what is the exactly the orchestrator is all about? So orchestrator includes some of the components. What are those components? These are the basic features of let's say the distinction of these components. If these components are not there, then we cannot call any resource it's an orchestrator. What are those? Those are scheduler, plus there should be something who is controlling every objects, right? So a controller, and something is managing everything. There would be manager also. So if any component, any application who can manage, who can control, who can schedule object. Object is what? Object can be either VM, either container. If a
Yep.
VM, if an orchestrator is scheduling, controlling, and managing a VM, it is called as a VM orchestrator. In our case, vCenter. If the orchestrator is scheduling, controlling, and managing any container, we call it as a container orchestrator, and then we have Kubernetes. So far, so good.
Yes.
So there's a basic understanding and idea. Now, what is this scheduler does? What is this container does? And what is this management system does? Similarly, just like in vCenter, you need it's a orchestrator engine, however, and it can orchestrate VMs. If one ESX goes down, my VMs get starts on second ESXi. The reason because I have a shared storage over here.
Yes.
Similarly, in my Kubernetes cluster, my storage, there would be a shared storage. This storage can be shared. The storage architecture, by the way, is totally different. So you cannot correlate easily. But I'm taking as an example of here we have a block storage also, right? Mainly
Yeah.
block storage.
Mhm.
So these block storages further moving ahead, we are creating data stores, and from the data store, we are creating VMDK files over there, and then those VMDK files are actually the form of virtual machine in software, and VM virtual machines are running over there. So it's pretty straight and simple. But here in to share a storage, okay, the here what we are sharing is a SAN LAN.
Yes.
It's not a file, it's a block. VMFS, the file system, is something which is making this possible to present the same SAN LAN to multiple or across the ESXi nodes. It's a feature of VMFS only. Otherwise, we cannot share a block storage across more than one system, isn't it?
Yes.
So the only storage type which we can share is a file storage. It can be CIFS. It can be NFS. Usually, these are the IP storage, right? We're talking
Yes.
as IP storage. We call it as a file system storage. So these storage, we can share multiple node, and nodes are further presenting these storages to pods. You have hopefully you have enough understanding about pods, right? What are
Yes.
they?
Yep.
Mm, Okay, so it's a very high level, but I'm trying to cover everything just
Yep.
for making the correlation and understanding clear. So this is file system storage which we can share across the worker nodes, and worker nodes are actually presenting those file system directly to the pods running. Uh, and this is happening. Sorry, gone. No problem. So so actually what is happening here is in this node, I'm sharing this NFS. This is mounting here in the host level, and pod is just getting a map. Pod is getting a map only,
Okay.
map of the storage. Okay, so I'll come to that. The in storage part, we would have kind of overall storage understanding. We would have network understanding in Kubernetes, and then further we have storage and networking, and then we'll talk about some uh, deployment methods which is we are going to cover, and then with the storage we will be talking about the config map, how we can make use of it in CKA, how the config map and secret components are coming there, what is the best use cases of all these config map secrets and everything. The nature of container is immutable. Do you understand what is this?
Yeah. So idea is that if it dies, I mean, it's ephemeral in the sense that we don't really care if the
If they
container
die,
lives or dies. Yeah.
that's correct,
Yep.
that's you're spot on. If we really don't care about whether the container goes down or it dies, something goes wrong, it's fine. We
Yep.
don't care. But why we don't care? The reason is, does it like we don't care about data? No, right?
Yep.
A container can have data, but the data would be in nature of codes, only and only in nature of codes. So there are programming code only, and those codes we are actually packaging within the container image. So let's say if one container goes down and it will, let's say, populate or form up a new container, the container will obviously come from an image, right? just
Correct.
like a just like a template, VM template. So whatever things we have already packaged into the image, it will inherit, right? It will come
Yep.
automatically out of the box with VM. So we are packaging codes only in image. And now, apart from the code, libraries, binaries, and the codes, what else is required? The else answer is storage, obviously. So the storage is something which is going to be map, as I said, map, right?
Yep.
That's why I use this word map. Storage is not going to present directly or attach directly with the pod here. This is not going to present here in pod. It's going to present on the host, and that is
Correct.
the only reason we don't care about it. If it is if it is going down, it's fine. From image, I'll get another container automatically, and who will take care of it? Who will take care? My controller.
Mm.
There are multiple controllers. We'll talk about it later on.
Yep.
So my controller will make sure that the number of replicas are same as in count defined, like 2, then it will be 2.
Yep.
No 3 or 1. We'll talk about the update strategy, etc., how we are upgrading
Mm.
DevOps and more other things also. I mean, beyond the CKA also we'll try to cover. So that is the only reason. I mean, my container is getting storage from host itself with the help of the mapping. And my container is, if getting deleted, it's fine. It's getting formulated from the template or image, which I already have. And it's getting all those data from a host map. So we really don't care about it. Uh, so far so good. It's just a very high level which we talk
Yep.
about, not
Yep.
in a very detail. Mm. So let's little bit talk about the architecture of control plane. In the control plane, so far we talk about 3 component. One is controller.
Mm-hmm.
Second, we talk about manager. Third, we talk it about
Scheduler.
is scheduler. Fair point. Then we talk about there are state also in vCenter, even how many number of VMs it's running on your infrastructure, and what is the matrix monitoring I
Mm-hmm.
mean the state of your
Yep.
vCenter cluster you need to store somewhere, and
Yep.
that is for that storage you need a database, isn't it?
Yep.
Data. So you are using in vCenter what? If it's a appliance, then that's Postgres with
Correct.
appliance. It's coming
Yep.
there. But if it is a Windows server, you set up your vCenter by your own by with help of vCenter installer,
Center.
then it would be what
SQL.
database?
SQL.
Microsoft SQL Server,
Yeah.
right? So here, just to maintain the state of cluster, we have a database. We call it as a etcd.
Yep.
Okay, it's etcd. It's a NoSQL database. Do you understand what is the SQL and NoSQL meaning?
Yeah.
Feel
So
free to say no. It's fine. I'll tell
yeah.
you.
So it's a key pair database, right?
You're totally right.
Yep.
So it's a key pair based storage. And when we talk about a key pair, it means two form of, let's say, importing, exporting, or applying anything comes in mind. One is YAML.
Mm-hmm.
YAML is a language where we only talk about key and pair, key value pair.
Yep.
That's it. And second is JSON. Here in JSON also, we only talk about key value pairs only. And that is the only reason, Arun, why Kubernetes accepts anything written in YAML and JSON only. It doesn't know C language. It doesn't understand Node.js. It doesn't understand Golang. However, the Kubernetes itself as a product written in Golang, but it doesn't care about it. It doesn't understand.
Okay.
That's the only reason, because etcd, the whatever state in my Kubernetes cluster is going to store there in etcd, number one. And because etcd is a NoSQL database, and that's the reason we're talking about key value pair. So, and for this only reason, only input or output method available is YAML or JSON, because these are the two languages only supports key value pair.
Okay.
One more point is, do you know what API is? You know it, right?
Yep. Yep. The
It's
APIs.
application programming
Yep.
interface. What it does exactly, Arun? APIs.
Okay. Yeah. So that's the main uh, way you will could communicate or uh, work with Kubernetes environment, right?
Yeah, that's right. So this is not about only in Kubernetes. In general, API is something which gives you a interaction point, because API is application programming interface. So it
Yep.
gives you an interface point. With that endpoint, you can post or you can get values,
Hmm.
right? You can post or get values programmatically.
Yep.
But those values always either accepts or let's say gives you as an output only in the form of this. What
Yep.
this is? Again, key value pair.
Yep.
This is the only possible way around, right? With while we're talking about API, we want to interact with API, we need to write our code in JSON. If you want to supply your instruction with curl, you need to put it in a JSON file format only. This is what API can understand. This is what API can accept only, right?
Okay.
That is the only reason, Arun, we have something as API. We
Yep.
have these 5 components now. Okay, what API does is Kubernetes master, because these all components are running there in Kubernetes master, it's fine.
Hmm.
But within Kubernetes master, if anything, any component wants to talk to Kubernetes and wants to talk to any other component, it should go via API only. Let's say I have multiple worker node W0, W1, they all, if this should talk to, this worker node component wants to talk to another worker node component, it cannot go directly, right? It
Okay. Yeah.
cannot go directly. It should go via only one thing, which is my API. So this is going to talk to the API, and further this is because API is
Hmm.
the ultimate single source of truth for every object. It is having all these entries, and API is further talking to HCD. Okay, let's say this worker node, or from this master node, you are running a kubectl command. Kubectl
Yep.
command, you are running get nodes, a simple, very easy command, get nodes. So this command is going to talk to my API here. API is going to query. This is a query you are making.
Yep.
You are putting a get query for nodes. So API is going to make a query here in etcd, okay, and then it will return you back whatever the query is. And etcd is maintaining the state of this, that I have 2 worker nodes.
Okay.
Okay, this is how things are working internally. Apart from this, we are talking about architecture so far. We not started anything on Kubernetes CKA yet.
Mm-hmm.
Apart from all these components, in Kubernetes worker nodes, how these Kubernetes worker nodes are communicating with each other, we said that it's API controller. But API controller, they are communicating worker nodes. If want to query about state, then it can go only with API. But how these pods are talking to each other? The pods are having internet
Yep.
networking within it,
Yep.
right?
Correct.
So there are when we talk about networking, there are two types of networking: service and pod. So we have service CIDR and we have pod CIDR.
Mm-hmm.
Okay.
Yep.
So every worker node get whatever /16 we are giving as a pod CIDR. Every worker node gets /24 out of that.
Okay.
Okay. And this /24, who is giving this /24 to the Kubernetes cluster? It's a CNI plugin who is responsible.
Okay. Yep.
Yeah, it's a CNI plugin who is responsible to give those IPs. That's the only reason, Arun. When very first time with help of QVD, do you have any lab with handy with you?
Um, I haven't deployed it, but I subscribe to the uh, the code
Code,
quota.
Metacota.
Yeah, yeah,
Mhm.
yeah. So over there, I have a bunch of layers which I can spin up.
Yeah, it's fine.
Yep.
That's a good lab, no problem. I will use my own home lab because I have installed and I'm installing it very frequently. So, uh, but if you have not, then I'll tell you because it's essential to understand all those things. It's a question usually in interviews, technical DevOps guys are asking. You need to understand the entire architecture, how things are working, then you will be easily uh, correlate things and you will be easily understand the logic, and once you will be able to apply your logic, you would be able to answer anything, right?
Yep.
That's how things are working. So when we are running kube adm, Arun, and kube adm command, with help of kube adm command we are installing, let's say we got 3 virtual machines, or let's say 2 virtual machines only. One we are we are willing to run as a master, and second we're willing to run as a worker. Then the very first command will run on master node is kubeadm. We'll get the binary downloaded and installed there in master node and worker node both. We'll get 3 binary: kubeadm, kubelet. Kubelet is an agent, just like if you
Yep.
remember VPXA. Do you
Yeah.
know is? Yeah. Similarly, there is kubelet. Kubelet is something who is responsible to send the heartbeat of nodes to the master. If let's say kubelet is not running, Kubernetes manager or control manager or Kubernetes manager will automatically declare this node as not ready. So the scheduler will understand that, okay, I don't need to span up any pods or deployment on this node because it's in not ready state. This is how internal collaboration works with each other.
Yep.
Do you understand kubelet
Yes.
now, right? Okay. So we need kubeadm to install Kubernetes. We need kubelet binaries to be available on worker nodes and master, just so that kind of agent which using this kubelet only all the nodes can interact with each other, networking point of view. And then we need kubectl. It's optional, by the way, for a worker node.
Yeah. Okay.
The very first command which we are running is this kubeadm. We are running here in master node and we are running like kubeadm init, and then we are giving hyphen hyphen like hyphen hyphen pod CIDR. We are defining what CIDR/16 will be keeping it. We can define 10.1.0.0/16. It's up to you. 192.168.172. It's up to you. We are giving it, but we are when we are doing it, my master node gets initialized. When it gets initialized means kubeadm will create all these containers. All these are containers, man. All these are containers, but what container? Static containers.
Okay.
I'll come on this point later on. What are the static containers? What are the other containers? Real containers are.
Yep.
We need to understand. So this kubeadm init initialize this, and it basically forms all these containers as static containers. So these container will start running here in Kubernetes master, and then it gives you one command also, kubeadm join command as an output. Okay, it
Yep.
generates a certificate also here
Mhm.
in this Kubernetes master. Then on worker node you are running that kubeadm join command. Now when you are running kubeadm join command, still your node will not come up. It will be in not ready state. Okay, even if
Yep.
you have joined. The reason is because this guy is not there.
Okay.
So very first time when you are initializing your master node, and further you are running your Kubernetes worker node, you are joining your worker node with the master. I mean, you are
Mhm.
forming your cluster overall.
Yep.
You will be able to do so because communication is there, and there is a component, we call it as a kube proxy. I
Yep.
will later on we'll talk about what is the role of it.
Mhm.
uh, it is playing really very important role because it's basically whenever kube proxy comes, think in mind NAT.
Yep.
Okay, IP table.
Yep.
So this is a role of it. We'll talk about later on. So your node can be added, can be joined with the cluster. You will be able to form the cluster, but your cluster node will still be not ready, in not ready state. It means you cannot run any pods because your scheduler will simply deny by saying, oh man, your worker nodes are not ready. How can I go there and schedule a pod?
Mhm.
I cannot, right?
Yep.
Yeah. And you cannot run a pod there because you don't have the pod CIDR. You getting it now?
Yep.
Once you are bringing up a CNI plugin installation, let's say Flannel, we'll talk about what are the differences also in
Mhm.
detail. We'll talk about the other things. Calico, ViewNet, a lot of other are,
Yep.
CubeNet, right? When you are installing this CNI is simply getting information from this HCD, let's say, that I had a defined pod CIDR of what? Of this. I had a defined CIDR of this. So this CNI will give all the worker nodes /24/24 as pod network CIDR, and it will make communication happens internally also between them with help of, let's say, VXLAN or overlay network for a pod networking, and then my node becomes ready. Hope you
Okay.
understand the entire logic. Feel
Yes.
free to ask questions and doubts.
No, so I think so far all is good. Uh, yeah, so, but I mean, it's good that we're going through that because then I can revise most of my understanding, and also I think it helps to better visualize some of the key components of the whole Kubernetes platform. Yeah.
Yeah, that's good. And my intention and my rationale behind drawing everything is just to make you recall about everything so
Correct.
that, I mean, we can best further, right? It would be only, let's say, 4 weekend, right? But we'll
Yes.
enough.
Mhm.
So this is how things running in Kubernetes. Uh, now once my worker nodes are online, I got worker nodes are online, I got the pod CIDR. We're talking about service CIDR also, right? So service CIDRs are not spreading there on worker nodes, just like /24 as pod CID or CNI is giving. CNI is giving this service CIDR range to this component Q proxy by saying, man, hold it with you. Hold it with you whenever I am forming any service. Get at least one IP address from that service CIDR. One IP address from that, and then NAT it, make a natting to the pods available over there. Okay, can I clear it out, right? Wipe it out?
Just give me a minute.
Yeah.
Yeah.
We would have this recorded session, by the way, for your info. I'm recording this session, so no
Yeah.
worries. Huh?
Yeah.
Just tell me and then I'll wipe it out.
Yep, I'm good.
Great. Lovely. Okay. So far, we talk about Kubernetes and its architecture. We are in very basic now. We never talked about what are the services are, what are the we are calling as one name pod. We understand so far that pod is something container. Okay. We'll discuss later on more about pod, because to understand microservice architecture, to understand applications, it's very essential to go ahead and learn about pod architecture also. There are the architecture. Hope you already aware, but I'm just trying to recall a high level so that we can. Yeah. So we talked so far about Kubernetes architecture. We never talked about Ingress services. Now we are going to talk about services, Ingress, etc., etc. Okay. So again, I will create, let's say, a Kubernetes environment here. Okay. You created one pod. This pod gets an IP. Pod CIDR gets an IP. But you cannot see this IP right now, right away, and it is just running, so it will not get an IP immediately, Arun. You can try it out by yourself also.
Okay.
If you run kubectl, if you deploy a single pod, let's say, let me see if I can open a connection here. Okay, this is my Kubernetes. I'm running like kubectl get node. I have these much of nodes. Okay, kubectl get pod. Okay, these are the pods running over here. Let's say I'm creating for you a new namespace. Okay, kubectl create ns and Arun, and then I'm kubectl run nginx simple and hyphen image is equals to where is my is equals to nginx, but I'm giving this time the namespace as Arun.
Yep.
This is how we can run a single pod now. kubectl get pod hyphen n get pod hyphen n Arun. One pod. Now, what else you will be targeting? Let's say if I say go ahead and give me a moment. I'm just aiding my keyboard. It's good. Now I can type at least. So you see here, right? I created, I run, I get pod, and the pod is running. Now I'm saying mainly just to get some idea about what IP address it is getting. What best you can do is you can first run -o wide. Okay, it gives you one IP address, but there is kubectl get svc. So far I don't have any service. Oh, sorry. -n Arun. I don't have any service. There are endpoints, right? Endpoints. Do we get any endpoints so far? No. The reason of saying you about this IP address in this Kubernetes is this. Our request, we are sitting here outside of Kubernetes. I'm accessing one thing, one application deployed. It
Yeah.
comes to, let's say, Ingress, a load balancer. Okay. Then this Ingress box is having an external IP and an internal IP. Internal IP would be a cluster IP. Cluster IP is always a service IP.
Yeah.
So this service IP is having a path-based routing and it goes to a service. Okay. And now this service is when you are exposing this deployment or this pod, then it becomes a service, right? We need to expose it internally. So when we are exposing a deployment very first time, it expose a pod internally, and this expose and this service is nothing but a NAT rule in kubeproxy.
Yep.
It's only a NAT rule. There is no object at all. It's just a NAT rule.
So
So service,
one
yeah.
question I have is that in Kubernetes, why is there a need to have the service itself? We could also expose the pod IP, right? I mean, do uh, that from the ingress itself. So why is this service required?
Okay, this service is required because otherwise we would not be able to manage these replicas. We
Okay.
need something we called it as load balancer,
Yeah.
right? So we need an internal load balancers who can load balance my pods. That is why we need a service. Service is nothing but we called it as internal Kubernetes load balancer.
Yep.
It's not, it's having no relationship with this. So forget about it. That is why we need a service. Service is doing what? It's doing it's doing natting between endpoints. Man, this is what I was talking about. Why I said ki IPs will have no means in pods. So we called it as EP. We called it as EP. So services can talk to EP only, and EPs are actually those where pods are exposing IPs. Services are talking to EPs, endpoints, and pods. EPs, you can consider EPs like, have you worked on any Azure cloud or AWS?
AWS, yes.
Okay, in AWS, for every EC2 instances, there would be NIC cards, right?
Yeah.
Interfaces we
Correct.
calling as a interfaces. So you consider that these endpoints are interfaces. We are connecting
Okay.
interfaces to the pod. Whenever we are creating a next replica, one interface populated automatically. And services starts talking to with the interface. They cannot talk directly to VM, EC2 instance. They can talk to interface. They will send the load balancer will send the traffic to interface. Now interface is attached with whatever VM or EC2 instance, it will get that.
Okay.
This is how endpoints, services, and pods are working together. Similarly, this is layer 4. Hope you understand.
Yep.
It's a TCP load balancing happening
Yep.
across the number of replicas. This ingress is layer 7. It's an application load balancer kind of.
Okay.
That is the only reason there is a single IP address. You are making DNS multiple A records, abc.com, xyz.com, right?
Mm-hmm.
Everything, every DNS records, A records are landing up to here in the same external IP. Now this same external IP is doing this host base. It is because it's layer 7, so it's intelligent enough. It can understand my packet header is having this host value. Host
Yeah.
values are being injected in packet headers.
Mm-hmm.
So it can, based on the packet, if it reads the packet, it's talking about abc.com, and this ingress controller reads the ingress rules. We are creating ingress, right? It reads the rule, and in rule we are defining that buddy, the host name is abcg, abc.com, it should go to the backend service abc.
Mm-hmm.
Then this is redirecting that traffic based on this ingress rule. Traffic is being redirected to
Yeah.
this service, and then further it's distributing. Yeah, definitely.
Okay.
You're getting all this ingress traffic
Yes. Yes.
component, how things are working.
Yeah.
Okay. I guess no confusion at all, isn't
Yeah.
it?
Yeah. It's clear. Yeah.
Great, great. We can have multiple ingresses, right? In one system, we
Yeah.
can have multiple ingresses,
Mm.
and which ingress we want to use is we can define further. But anyways, forget it about it. Let's discuss. I can wipe out this screen, right?
Yes.
All right. Let's talk about a pod only. A pod is nothing but an abstraction. It's a layer, you can say, right? It's a layer. It's a wrapper. It's only a wrapper around container,
Yeah.
real container. So it's a container one, let's say. It's a container two, let's say. And both the containers are in single wrapper. And uh, this wrapper is getting further one IP. This would be my pod IP. Internally, they are talking with each other via localhost. That is the only reason same kind of containers cannot be present in a single pod. Nginx running on port 80 plus Nginx running on port 80, you cannot have, isn't
Right.
it?
Yeah.
You cannot have. But same point in time, Nginx, Nginx as a pod in same namespace, you can have multiple
Yeah.
because they are getting a different IPs here. Okay, it's just for a recall.
Yeah.
Okay, let's talk little bit about.
So actually,
Uh,
do you mind like going a little bit deeper in terms of the pod, right? So I understand how it works, but like, what's the main purpose of having that wrapper on top of the container?
yeah, I'm going to talk about it.
Okay. Okay.
So I was about to discuss these two concepts, init container and sidecar container. What does it mean? Both of these having different functions.
Mm-hmm.
Init container, as its name, it's a container which helps to initialize another container,
Okay.
right? So let's say you're doing a deployment and you are defining you are do you know liveness and readiness probe? What are
Sorry.
liveness
Lit.
and readiness probes?
Oh,
Live,
no, I'm not sure
no.
about that. Yeah.
That's fine, no problem. We are here to understand, so
Yeah.
it's fine. Hmm. We are going into deeper. now. So init containers, let's say we are writing a deployment where deployment is kind of programming we are doing. We are writing our logic, etc. also. So let's say I have one container, two containers here. Container one, in this deployment, we have two container. One container is Nginx container where I have codes also. My website code, static HTML codes are there, but I'm copying these codes. I don't have this code, by the way. I have symbol Nginx container. I'm I'm trying to fit one logic. I have one Nginx container only. There is no code within it, but I have a code written there in my Git repository. I'm trying because my codes are keep on changing.
Yeah.
So my logic, I'm trying to apply one logic that someone should pull the code. Step one, pull the code. Step one is sorry. Step one says run Nginx. Step two says pull code in var www html, and then step 3 is nothing, forget about it. So if you see, running Nginx is very easy, right? Pretty straight. But while I started running this Nginx container, I'm getting a PV also here, right? Storage. So let's say this is my container. This is my, I need two container then. Container, I'm not talking about pod.
Yeah.
And because those are container are part of the pod, so sharing all the resources, including network also.
Yeah.
So I got persistent volume here, which is attached to the pod now. Because they are sharing everything, so whatever command they want to run, they can run here without any problem, and that command will affect each other. They are sharing storage also. So I will write one container Nginx definition, and I will write another container with a command git clone and the repository name. CD, that command, that container will run and it will do simple job. It will run and it will do a cd space var www.html, and then it will run a git clone. That's it. So my Nginx container starts running. My this container is doing a job of this pull change directory cd plus pull job. This container is doing. So and then it dies. It will not, I mean, it will not keep on running, but because it is defined there in my deployment file, so whenever my pod is getting deleted, this entire pod is getting deleted every time from the deployment configuration, the same scenario is happening again and again. Did you get the entire architecture here?
Yeah, I think so. So, what is happening is at first, from the deployment perspective, we will run the init container, which will run the Nginx image, and then
No, in
you will
sorry,
run.
sorry, sorry. Init container is this,
Oh, okay.
because
So,
init container is responsible to initialize this container functionally.
okay. So,
Okay.
okay, in the pod, in the image here, we have two containers, right?
Yeah.
So, number one is running the Nginx, correct?
Yeah.
And
Yeah.
number two's job is to spin up whenever we need to pull the code and
Yeah.
add it to the directory.
Yeah.
So the number two is the sidecar container.
No, 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 no. I'm going to tell you. So far, we didn't talk about sidecar container. We are still
Okay.
talking about init container.
Okay.
As I said, the definition says init containers are those containers which are responsible to initialize or which are responsible to perform certain tasks which is required to initialize another container.
Okay. Okay. Understood.
Right? So
Mm.
Nginx container, if it is running, there is no means to run it alone without any code.
Yep.
Okay. We are doing before, I mean, with deployment, this container is both the containers are running at the same time because both containers are part of the single pod.
Yep.
And if you will see the status, you will get 2 by 2. It means two
Mm.
containers in the pod.
Yep.
The first pod, Nginx container, is started running. So far, so good. It's fine.
Yes. Yes.
Nginx container is started. No problem at all.
Mm.
Before making it live, I mean, before this pod says that I am ready. By the way, if your pod status is not ready, it means if it is 0 by 2, it means it is not ready. Your service will not route any traffic to the pod.
Yep.
Okay. Once it
Okay.
is 2 by 2, then your service will start sending
Mm-hmm.
traffic to the pod. My pod status is 0 by 2 so far. And this 0 says what? It is running perfectly fine. It may be running. You may find containers pod status as running, but this 0 by 2, it means my pod is running, my wrapper is running,
Mm-hmm.
but internally my two containers are not yet ready.
Okay.
So the when it will they will be ready when this container is running. Now this container is running. This container, when it runs, it performs some operation, one time task. And what it does, it made a cd to this directory, then it clones this git directory.
Mm-hmm.
Codes are now available here, and once the code are available here, then it becomes 2 by 2, and now service starts sending traffic.
Okay.
Now my website is live.
Mm-hmm.
Okay, so hope you understand the init
Yes.
container are those container which are doing a one-time task to initialize another container.
Okay.
As its name, it's init container. These are performing certain tasks which is required to run another container, and init container and another container would always be in a single pod.
Okay.
Okay, so this was a
So
use
uh,
case.
just to check one last thing, right? So when it initializes the other container to do the code pool,
Mhm.
after it is done, that other container will be gone, right?
No,
So
because
it will stay.
see, pod can be die, container cannot die. Container will be non-functional because it perform its jobs.
Yes.
It stays there because the
Okay.
status is 2 by 2.
Yeah.
Means in one pod there are two container. One container is keep on running, right? Nginx.
Yep.
It's serving all the purpose. This container was required, another container was required only to perform, let's say, pull.
Yep.
It does its job and it's fine. It stays there idle.
Okay. Understood.
So this container keep on serving you.
Okay. Okay. I understand.
Good. Now talking about the sidecar containers here. Hope it's good to wipe out the screen.
Yes. Yes. It's good.
What are the sidecar containers? Hope it answers this your previous question also. Why we need multiple containers in single pod?
Yes.
Great. What about the sidecar containers? What are they? Then the sidecar containers, as its name, just like a bike, scooter sidecars, these are running parallelly. See the major difference. Init container is responsible to run a one-time certain task, certain operation. It performs and then it handovers everything to the another main running containers. It works just to initialize the another container. It means there is something we call it as a main container, and the init container is just run once to perform certain tasks. That's it. Sidecar container, as its name, it runs parallelly, side by side.
Okay.
What is the use case and functions? Let's try to understand. Let's say we got a pod here, and it's a container. It's a container again. Now, the best scenario is about service mesh, but I'm going to give you some other scenario. It's not practical. I mean, it's practical, but don't go in very detail because we can learn it in some other security topic.
Mhm.
I'm just giving you an example only. These are two containers and this is a pod. Let's assume um, this is my main container, or let's say app container. Do you know that pod to pod connection within Kubernetes are unencrypted? Do you know it?
Yeah.
There is no encryption between pod to pod or service to service communication. It means if some hacker is able to populate or form one container who can intercept traffic within the Kubernetes, he can get anything
Okay.
because the entire traffic is unencrypted. So if it is unencrypted, now if we need to encrypt the traffic, I have another pod now, and I got two containers again here. Container 1, container 2. If these are the main containers, let me give in some different colors. These greens are the main application containers.
Okay.
These are the containers as running as proxy. Not only proxy, reverse proxy.
Mhm.
So how the traffic is moving now? Traffic is moving. Traffic is going to here. And then from this container, traffic is moving to this. And from here to here. In similar fashion, this to this to this, and this to this. If you see here, this container plays an important role. It should run throughout the life cycle of the pod.
Right.
Okay. What work it is doing? It's working continuously. Wherein if we compare the init container does the job, its job, it does, and gone. But sidecar containers are running parallelly and they are actively working. So here the sidecar container is doing what? I am putting a CA certificate and a certificate and a key. Same thing here also. Okay. So what they are doing is they are making this traffic encrypted. This traffic between them is encrypted. This traffic is still not encrypted.
Okay.
Okay. So encryption and decryption these sidecar containers are doing. If let's say they need to apply any rule that there are some other also two containers, one pod, and we want to let's say connect this to this, but we want not to connect this, then this sidecar container helps here to put a rule because it's a reverse proxy, right? Layer 7.
Yep.
We can put a rule, right? This host is not acceptable.
Yep.
This is acceptable only. So hope you understand what is the function of this sidecar containers now.
Yes.
And what is the function of init containers now.
Yep.
Happy?
Yes.
Great. All right. Uh, Next, I'll talk about service. We talk. It's a layer 4 load balancer only. Nothing special to talk about it. But yeah, special is to talk about the types of services. You are aware already that there are 3 types mainly, right? Node port, cluster IP, and do you understand, right? You know it.
Yes.
There are 3 types. What are the differences? Let's understand. This is my parts. This is my service. Now, if and this is my node, by the way. This is node. When I say node, means my worker VM. Okay.
Okay.
So if I am defining node port, what will happen? Node port says that there will be there is a NIC card attached with this VM, right?
Yes.
So this with this NIC card, we already have external IP.
Yep.
At the end, if you see Arun, the our motive is to expose our services, whatever component we are running over here in this container. If we are not able to expose it externally so that someone can access it, what is the meaning of it, right? Nothing.
Yep.
So the services are, there are 2 types of services, this one and this one, using which we can expose our service directly to external. What it does, when we are creating node port as a service, this service is having internal IP. Service CIDR, from the service CIDR pool, it will get one IP. So kube proxy is doing a natting between this.
Okay.
Hope you're getting. So it's
Yep.
doing a natting between external IP to the internal IP of service. So whatever traffic I'm trying to reach, from this place, my laptop traffic will move to the NIC card IP address, and from NIC card IP address to this service, and from this service to obviously load balanced here. So I'm able to reach out to the application pod, isn't it?
Yes.
Yes. This is a type of node port. Restrictions are what? I cannot expose the second service on the same port. Reason is simple. They are sharing the same external IP and same interface. Same IP cannot have same port services.
Correct.
So this is a restriction. That is why in node port we have random port concept. Random external port concept. We are getting something like 18052, one port for one service, 18053 for another service,
Mm.
18054 for another service. This is, we cannot get 443, let's say, or
Okay.
port 80. We cannot get it. There is a restriction because they are sharing the same host IP, etc.
Right.
Let's discuss about another type, that is load balancer. Let me wipe out this. AWS you have worked on.
Yep.
Okay. These 3 are my pod replicas, and the bigger one is my service. Now, When I'm doing a load balancer, when I'm exposing my service as a load balancer, obviously it will have one internal IP. It will have one internal IP. What it is doing is there is external load balancer with me, and it is having external IPs.
Mm-hmm.
So there is a map, there is a happening with external IP pool, by the way. I would say it's not a single IP. There would be in load balancer service, there would be external IP pool. So whenever I am exposing my service as a load balancer, what it is doing, it is from this IP pool, it is getting one IP and creating a map with this service. Again,
Okay.
this map is
So
NAT.
that this LB is it ingress or are we talking about external LBs like F5?
Any external IPs. By the way, F5 we cannot make it here. I'm talking about AWS NLB.
Okay. You're talking about AWS. Okay, yeah, sure.
So one load balancer, it will create in external load balancer, let's say, and then it will map. And this is a special case, Arun. That is the only reason you cannot create this load balancer service type in your on-premise. Your external IP always go in pending state.
Okay.
Your always why? Because there is no external load balancer supported to the Kubernetes, right? The reason is because the moment you created this service type as load balancer, there would be one ARP request. Okay,
Mm-hmm.
there would be one ARP request which will start broadcasting. Now this broadcast, your load balancer here, your load balancer is sitting around here, and your load balancer is only that kind of load balancer can work here who is able to listen ARP requests.
Okay.
So whatever ARP request it is, this is broadcasting the ARP, and this load balancer is listening the ARP. So it's
Right.
listening. When it gets the ARP request, it immediately created one IP load balancer and assigned one IP pool.
Okay.
And
Okay.
then because now this service proxy is having understanding, oh, I get a ARP request and I got a load balancer assigned. So it creates a NAT rule here.
Okay.
So if your load balancer, F5 load balancer, let's say, is not able to create this kind of ARP, etc., it's not possible, right? And your Kubernetes, by the way, in your AWS environment, your Kubernetes is having inbuilt capability to talk to AWS load balancer, man. If you are
Okay.
using, let's say, F5, and F5 is even possible to listen the ARP request, it cannot serve this purpose. The reason is because F5 respective agent needs to install in your Kubernetes environment, because your agent will send ARP request to the load balancer to F5, and then only it will assign you one IP address, otherwise not.
So in this case, the AWS has an agent that is running in there to listen to ARP uh, requests, or
Hmm.
how is it happening?
Agent is not required for AWS because Kubernetes, in Kubernetes solution,
Okay.
this is incorporated when Kubernetes vanilla flavor product was written. When it
Okay.
was written in Golang, they already incorporated some of the well-known cloud providers load balancer already. Azure, you will
Okay.
get it. Google, you will get it. You will get it even for let's say this AWS, but you cannot get from every cloud provider. There are some
Okay.
less known cloud providers like Hetzner. There is
Yeah.
no inbuilt tool. You need to create a agent, right?
Understood. Understood.
Some of the
Okay.
native out of the box agents are available there. It's not
Mhm.
visible. It's there in product itself, product code itself, I would say, rather.
Okay. Okay. Understood.
Okay. This is how your service load balancer is working. So far we talked about this. So far we talked about this.
Yeah.
Any question?
No, clear.
Perfect. Uh, so the next is Next process is you can expose your service as cluster IP. Here the problem starts. Why I am saying so? Let me explain it a bit more. Node port, we talked about. Load balancer, we talked about. So far so good, no problem. Load balancer we cannot use. So you understand that for production use cases, node port is not a option. Why? Because it's creating unnecessary random ports, and our application can run on standard ports only, not on random ports, right?
Yeah.
So this is the only problem. Load balancer are okay because we can run 44380. But the problem we are getting is what? Unnecessary cost. For every service, you need one load balancer. Every service type load balancer, if you are exposing in Kubernetes, it will create one dedicated load balancer for itself, and it will map with the service. So let's say 100 of application pods are running, and you are exposing 100 of services, you will get 100 of load balancer created, which will create unnecessary cost. So what is the other option? Other option is, now we are going to talk about Ingress. That is why we have Ingress, Arun.
Okay.
Let me draw the architecture now. If you remember, I talked the load balancer. Please remember that design. It's a pod, it's a service. I got one, or let's say I can get two. It's fine. ARP request going, talking to load balancer, creating as ELB external IP pool, one IP got created. So what we are doing it, we are deploying one ingress controller. That ingress controller will be deployed as a deployment, let's say, and it is creating one load balancer outside. Now mapping happens. I created another service. This becomes cluster IP, exposing it as a cluster IP. So it can internally talk to each other, right? It can internally, service to service, they can talk to each other. That is why they can talk to each other. Now, what I'm doing is, my request, I am creating here ingress rule. And in that rule, as I said earlier also, I'm defining that abc.com DNS will resolve this external IP of load balancer. This load balancer has a NATed to the cluster IP of ingress controller. Ingress controller is reading a rule defined in ingress rule here, and the rule is talking that go and send to this service, and this application reach first request here, second request here, third request here.
Okay.
Now I can have multiple ingress rules.
Right.
And I can have multiple services.
So basically, we are creating IP tables to maintain the access for different services to different cluster IPs.
That's correct. Basically, we are creating rules here, not IP table. These are ingress rule. Ingress rules are defined in ingress controller.
Okay.
Ingress controller, these are the objects, ingress objects. You are, whenever an ingress controller is getting a traffic, it's reading in the header what is the host name, and the host name, then it's reading to this rules. every rule. Let's say 50 rules, it will read all the rules and it will match the correct host name. Once the correct host name rule is defined there, then it will read, okay, it's going me to redirect to this pod, I will reach it there. And that is the only reason, Arun, this is
Okay.
working on layer 7, Arun, and that is the only reason it can get high load also. That is the only reason we have an option to scale this all out also.
Okay. So ingress rules are called ingress objects. Is that what you said?
Yeah, you're right. And we are creating multiple ingress
Okay.
based on, we are not creating ingress controllers. Controller is a one-time controller. When we need to, let's say, expose our, we are doing any deployment, we are doing deployment, and then we are creating service, and then we are creating ingress object. So ingress object is nothing but a rule. Controller is a one-time task. Controller is a controller, man. It's a controller. It's a master object.
Okay.
Okay. It's reading it. What is the task of it? It is reading whatever rules you are creating for every services, and then it's redirecting those traffics only. It is working as a layer 7 load balancer here.
Understood. So to check the difference between node port and cluster IP is that node port is meant to directly provide the netting and provide access from external network to the service itself, and
Random port.
uh,
Hmm.
in terms of cluster IP, it is not meant to do that, right? So cluster IP is just serving internally within Kubernetes, or how exactly?
Internally, always. See, cluster IP is required in all the cases. If we are creating, let's say, node port, service will have only the cluster IP. Node port is something which would be the external IP. So there is again a netting. I mean the relationship between service cluster
Okay,
IP and then
okay,
node port. There would be again the same scenario, but now the relationship is happening with external load balancer, right?
understood. Yeah,
And then now when we are doing again, then the relationship is happening with ingress object.
congrats.
I mean,
Okay,
you have entry point either from this, either from this, either from this entry points just to reach internally to Kubernetes, but internally mapping is happening within the cluster only, and cluster IP is a service type, and then it's further sending traffic to across the pods.
okay, that makes sense. So in a way, Ingress firstly helps to provide a more scalable solution, unlike I would say the load balancer option where you will end up creating multiple load balancers, and that will in fact increase
Incur, yeah,
cost. Yeah.
incur extra cost. Yeah,
Yeah, and
yeah,
in terms
that's
of
right.
Notepad, what is happening is it's
Non-standard.
the
So
benefit is that you can fix the particular pods, and that way you can maintain the security of the environment.
yeah, you're right.
Okay,
You understood well.
yeah.
Okay. So far we talked about node ports, we talked about service, we talked about this. Now we will try to little bit talk about. Okay, let me give you one more. Fine, we'll discuss later on. Now we will talk about. Can I wipe it out?
Yes.
Okay. Now we'll talk about the other objects like secrets and config map. Storage. Let's discuss first about storage.
Okay.
So how the Kubernetes workers or pods are getting storage. There is a concept about PV.
Mhm.
There is a concept about PVC. Do you know
Yes.
all these?
Persistent volumes and persistent volume claims.
There is a concept about SC also. What is it? SC?
SC, I'm
Storage
not
class.
storage class. Okay, yes.
This only when there is only PV and PVC, we are calling it static provisioning.
Okay.
I'll come to that. Static provisioning of storage. To pod. When we include this also. Then we called it as dynamic provisioning.
Okay.
Of storage to the pod. What is the difference between these two? The difference between these two is one says that you need to create a PV first, PV definition. What is the definition? I would take this name many times. So definition is YAML manifest file. Bear with me. PV definition I will write myself. PVC definition then I will write myself. Then I will add them in pod definition, or let's say deployment. Okay. Everything I am doing is manual. I'm creating PVC. I'm creating first PV. I'm creating then PVC. I'm then adding it to deployment. What if I need to, let's say, create a claim only? Claim of 5 gig. If I'm making a claim of 5 gig, it means I'm writing a PVC only, and this PVC should talk to storage class. Storage class is having definition of, let's say, 3 or 4 types of storage: file, block. Okay, these 2 types of storage mainly, let's say, available. In my PVC definition, I'm just only doing it what? Claim of 5 GB file storage. Okay, I'm defining the storage class name only. And what it does, the claim is going to talk to SC. SC is having definition of this file. SC is creating a PV, persistent volume, from the underlying storage. And once I get PV, PVC I already had, I can mount it easily to deployment. This stuff is called it as dynamic mode of storage provisioning. Hope you get it.
Yes.
Have you worked on all these, or still need to work?
Sorry, you mean like, have I practiced this before?
Yes. Have you practiced all these 2 types before? Any point in time? Yeah.
Yeah, I have.
Great. It's good to have you. I mean, we'll probably end up very soon.
No, I'm sure I've learned many different things from you, so
Yeah.
yeah, it's great.
Good to hear. So these are the concepts of the storage. Now this PV and PVC and SC, based on this storage concept, these are the storage, I mean real storage, right? The file and block, where you can go ahead and store random data, right? Anything. File storage and block storage are mainly used for putting anything. If you have binary file, you can put in there, no problem at all. Exe file, libraries, binary, anything, any data you can put in there, file or block, it will entertain, no problem at all. What if I need to put environment variables? Variables are not static, right? That is why the name is variable. Let me wipe it out and then I'll make you aware. You created a MySQL pod, SQL pod.
Okay.
You created a very shiny website.
Okay.
Again, it's a pod. Now you are connecting them together.
Yeah.
Obviously, you have a underlying storage. You getting data for this.
Yep.
You're getting data for this also. This to store code and this to store DB.
Yep.
No problem at all here. But when
Yep.
this pod is making a connection, it needs credential, right?
Right.
Database name. It needs further DB user. It needs DB user password.
Mm-hmm.
We cannot hard code it in the application because then it will be visible here in the database. If it is NFS
Yep.
and it is mountable on any other machine also, someone can mount it and they can easily read whatever things are there, right?
Yes.
It's not a best practices. So what is the best practice is where we can store. It needs to store somewhere in some file or in environment variable as an environment variable. So
Right.
what we will be doing is then we need something other storage type. We called it as secret.
Secrets. Okay.
We can create secrets from files. We can create secrets from environment variables also. Okay.
Mm-hmm.
In similar way, let's say the code are okay, but the web server Nginx which is running, it needs multiple configuration. Maybe I want only those some of the configuration to be changed, and for that I don't want to, let's say, redeploy or package those configuration all the time into my image.
Yes.
So I need what? Config maps. Config maps are mainly used to supply or to mount a configuration file within the pod, into the pod.
Okay.
Like nginx.conf is a one file. I can create a config map and I will mount it as a volume. These all things, by the way, goes as a volume. I mean, the secret also goes as a volume. This config map also goes as a volume.
Okay.
We can mount it and we can give it a proper path. So I'm nginx.conf, I'm mounting. If it requires to mount in /etc/nginx, it's fine. I'm mounting in there. What we can do best is we can modify config map whatever time and how many of the time I need to modify. I can modify any of the parameter, and because this config map is getting mounted here in application, then application will read that config map as a file. So anytime I can modify the parameters. I'll be able to do any perform any modifications over here in this part. That is why the config map is being used. Now the difference between secrets and config map are secret every data values, because it's a key value pair, right? So the values are encrypted in base 64 encryption, but in config map these are flat.
Okay.
However, we can mount entire config map or this, let's say, the nginx.conf configuration file with help of either secret either config map. It's up to us. If we don't want to mount that configuration file as encrypted in base 64, we can use config map. If it is having any sensitive value also, then we can mount as a secret encrypted in base 64 encryption internally. Did you get what I'm saying?
Yes. So, in terms of, so generally, where would you store the secrets and config maps?
This is what I said. if the file is, or let's say the value, key value pair, then I'm talking about that particular value. If it is a file, then value would be data. So if the data or the value is sensitive in nature, like having containing user IDs and password, etc., secrets, etc.,
Mhm.
then we'll be creating as secret.
Yeah, so I understood that. What I mean is that that secret YAML file itself, is it stored in etcd or is it stored in external storage? Typically, normally, where would you keep these config maps and secrets?
Oh, okay. So these we are not keeping them somewhere. It's definitely whatever these are when we are creating these secrets and config map, we'll be creating as a YAML file, and then we'll run kubectl apply or kubectl create -f and the YAML file, and this object will be created. Everything within Kubernetes is an object, just like pod, just like volume, PV, PVC. These secrets and config maps are also objects. We are creating from YAML files,
Mm-hmm.
or we are creating from the command line. So once we are creating, these becomes part of the cluster state, isn't it? So
Ah,
this
okay.
will get stored there in where? etcd, everything.
Okay.
Anything which becomes part of the cluster state goes directly in etcd.
Okay.
You can query with API like
Yeah.
kubectl get secret name, and then so this kubectl get, kubectl create, kubectl apply. What is this? This is all the API calls which you are making, and this kubectl binary is making all those calls with help of what? Every time you are putting a YAML. YAML is before doing this apply, it is converting itself in JSON. We are not able to see that, but it's converting. So I mean, this is how things are working in Kubernetes.
Okay.
Hope you're able to understand, right?
Yes.
Great. So that's it for today, Arun.
Okay.
Uh, hope it was good session for you.
Yeah, it was great actually. So I think helps me a lot because I know most of these things, but in terms of how they interact, some of the key
Mhm.
differences
Mhm.
between these different, for example, components, uh, is really helps to get a deeper understanding of the whole Kubernetes platform. So I think yeah, it's very useful.
I'm pleased to hear this. So next, what I will be doing is tomorrow I'll
Hmm.
try to make some agenda
Okay.
of every CKA topics, let's say, and we will cover every topic in depth. So from the CKA point, this was the warm-up session, you can say,
Yeah.
today. And from tomorrow onwards, we will be covering the CKA agenda, and then we'll practice those CKA real-time questions also, let's say, if it is there, right?
Yeah. So done.
However, I can understand from your knowledge and understanding that you are actually good enough to let's say appear for CKA. CKA is not that much difficult, but
Okay.
yes, I will make you aware about these knowledge, these understandings are required in examination also. If you're done with all this understanding, it will be very easy to crack this
Okay.
exam.
That's great.
Okay.
Actually, just another question I have, not related to what you're doing, but like for CKAD, how different is the exam compared to CKA?
There is a agenda differentiation in terms of all three certification. It's not complicated. I would not say it's complicated, but CKA is more towards not dealing with upgrade, patching, deployment, etc. It's more
Mhm.
towards how you are managing your Kubernetes cluster.
Yep.
Like you say, I can stop my kubelet, and I can see that there is a node goes in not ready state. So
Yep.
if this situation is there, I need to find out the root cause, and then I need to fix it. This is what CKA tells us. The
Right.
entire agenda is all about config map, how you can use it, secret, how you can use it. Some topics are common in both CKA and CKD, just like the use of config map and secret is very common.
Right.
The use of I mean running the containers is fine. Running containers with help of secret and config map is something which is also there.
Okay.
A lot of other things are in CKAD, but with CKA mainly we are talking about platform. So
Okay.
they both have, I mean, seek different paths, right? So
Okay. Okay. I understand. Yeah. I mean, I think something I probably would want to follow up after CKA. So, yeah.
okay,
Yeah.
fine.
Okay.
All right,
Thanks.
I'm stopping the recording now, and